I am Anil Kumar. Welcome to my series on patterns and relationships. Let me thank all the viewers and subscribers for taking keen interest and posting their request on this topic. In this video, I'll talk about many things which will include finding rules for writing patterns. We will have one particular pattern. The three figures shown here is a growing pattern. We are going to discuss this pattern and write different rules which will show how this pattern grows. That's the whole idea. We'll begin with iterative rule first and then explain you how to form a t-table, how to write the rule, rather describe it, and find the number of squares in the fifth term. Now we'll extend this rule to algebra. We'll then try to see how we can actually describe the rule in terms of term number and value of term, right? So we'll actually take help of algebra in doing that. So that's something new for some of my students in middle school, and I hope they will enjoy it. And once you understand all this, then we'll take up two questions for you. You will have to write algebraic rule for this pattern, where this, as you can see here, is fixed number and those are the boxes which are growing. Defining a variable, you have to write algebraic rule for such a pattern. And we have the same pattern once again, but you could write different algebraic expression to show how you can find the value of term number. Even if you want to know how many boxes like this or squares will be there in 100th term, you will be in a position to find it with the help of a formula. So that is what we are going to cover. I hope you find it interesting. So let's begin with what you really know, and then we'll get into things which you want to know. We are given a pattern which you see here, and we'll try to write an iterative rule to describe this particular pattern. You can always pause the video, answer these questions, and then look into my suggestions. Question number 1. Make a t-table to show the term number and number of squares. Okay, so let us call this as our first term, second term, and third term. You have been calling them also as figure number, right? So we are calling them now as term number instead of figure number. So in the first term, we have 3 squares, right? In the second term, we have 3 plus 2, 5 squares. And now we have 2 more, 7 squares in the third term, correct? So to describe this, we can always make a t-table. So let's make one t-table. We'll write term number. So I'm writing number with this hash, right? And we'll write term value. Value here will mean number of these squares, right? So in the first term, we have 3 squares, so the value is 3. In the second term, we have 5 of them, and in the third term, we have 7 of them, correct? So that is the t-table which you are familiar with, correct? So let me write here t-table. So that's part A. So make a t-table to show the term number and the number of squares. So the number of squares is the term value which I have given, which I am writing as term value. Part B is write a rule that describes the pattern. Now normally the rule which we write is start at some number. So we are starting with 3, right? So the rule here is start with 3 squares, and then what do? you add 2 each time. Add 2 each time. Right? So if I want to know how many squares will be there in the fourth one, we have to add 2, correct? So the number of squares in the fourth one could be adding 2, right? So if you add 2, you get 9. Perfect. So that is how this pattern is growing. Question number C is, how many squares will be in the fifth pattern? Okay. So to get to the fifth pattern, we'll actually follow this rule, right? So in the fifth pattern, we'll again add 2 more. So we'll add 2. So when you add 2 to 9, you get 11. So we know that there'll be 11 squares in the fifth pattern. So this particular rule helps us to find the term value, or in this case, the number of squares in the given term or in the given figure number. Does it make sense to you? Now, there is a difficulty. Difficulty is that if I tell you how many squares will be in the, let us say, 20th term. Now, what will you have to do? You have to extend this table and keep on adding 2 each time till you reach 20. That will be a very difficult job, and it is going to take long time. And if I say 100th term, then it's even more difficult. So this method, which we call iterative rule, iterative means repetition, right? So what do you repeat? You start at some number and keep on adding 2 each time. So we are trying to find the number with reference to what we already have. So we add them and then grow it. You get the idea, correct? So that is the limitation, right? So getting to this stage is difficult. It takes lot of times, right? So it takes lot of time. You can do it, right? But it takes lot of time. So what can we do? We take help of algebra, and that is what we are going to learn in this video, correct? So let's move on and see how we can help ourselves to find quick solution to such problems. I hope you enjoyed the break. We took a small break, showed you some ducks which were enjoying the freezing water of Humber River. Could you count those ducks? No, it was very difficult, right? There were so many of them. We couldn't count because we could not figure out any pattern to count them fast, right? So in that small clip, it was difficult to count since there was no pattern. Patterns actually help us to count faster also. Now, let us understand few tricks how to form patterns when we are given situations which seem to be random. Perfect. So algebraic expressions will help us to do that. Now again, we have the same expression, but the questions are a bit different. First one is, how is the term number and the value of the term related in the above pattern? So what we understood is we just made one table, and from the T table, let me repeat that part, right? So from the T table, we found that term number and the term value. In the first, we have 3. In the second, it is increasing by 2, right? So 3, 5, 7, and so on. So that is how they are related. Now the question here is, how is term number and value of term related in the above pattern? So that is to say, this is our term number 1. This is term number 2. This is term number 3. Now, in term number 1, what is the value? Value is number of squares. The number of squares is 3. The number of squares is 5. The number of squares is 7. The question here is, how are these numbers related? How is 3 related with 1? How is 5 related with 2? And how is 7 related with 3? And so on. That is what we need to figure out now. Do you get the idea? So how do we find this? Well, we'll take help of algebra. So what we do here is, we have 1 term, 2 term, 3 term. So what we will do here is that, let me just shade in one of them, right? So let me shade in one of them. So one term I shade in 1. In the second term I shade in 2. In the third term I will shade 3. Sorry. So only 3, not this one. 1, 2, and 3. If I shade like this, and if I have n terms, do you understand? It could be like 10, 20, 100. How many of these shaded things will be there? There will be n of these. Do you see that? Perfect. So we'll have in nth term n of these shaded. How many are not shaded? Now let's figure out how many are not shaded. So for that, in the first term we have 2 not shaded. In the second term we have 3 not shaded. In the fourth term we have 4 not shaded. So that is n is shaded. Let me write down, right? So we have n is shaded. And not shaded is how many? If you relate with this number, it is 1 more. So what we find here is n plus 1 is not shaded. Do you get the idea? N is 1, so 2 are not shaded. In this case, 3 are not shaded. 1 more than 2. 1 more than 3 has not been shaded. Correct? So now let's look into the question. How is term number, which is n, and the value of the term related in the above pattern? Well, the relation is simple. The value is equal to n plus 1. We can just add them all, right? So that gives you 2n plus 1. Do you see the relation? Which you could also write n plus 1. N which are shaded and n plus 1 which are not shaded. Do you get it? Part B is write a rule that tells how to calculate value of a term using the term number. So in our case, the term number is n, right? Let me write. Let term number be n. So the value of term number is how much? We just found. You could write this as n plus 1 or 2n plus 1. Do you see? Add these two n's. Like adding 2 apples. You get 2 apples. Think like that. 2n plus 1. Perfect. So that becomes an algebraic expression for us. So this is the relation. You could either write n plus 1 or 2n plus 1. Now how does that help? That is going to help us to find the value for term number. Let's say if I go to term number 20, then what should be the value? It will be 20 plus 20 plus 1, which is 41. Do you see that? N plus 1. So easily, without going through all of them, we can find the value. So I hope now you understand how to find the number of squares in let us say 100th term. In 100th term, how many will be there? Well, it will be 100 plus 100 plus 1, that is 201. Simple as that. We do not have to add all of them. And this type of pattern rule is called explicit pattern rule. Is that clear? Perfect. So the explicit pattern rule, which we just found, helps us to find the value or the number of items in a particular term easily by having a formula. And we really call it an algebraic expression. Perfect. Now to give you practice, we'll have two examples for you. And we'll try to figure out a way to relate them just as we shaded here. You could do that and then find the solution. Is that okay? So let's look into these questions one by one. Here is an example. We have the same pattern, right? But different kind of shading. Do you see that? Your question here is to find pattern rule. And this is question 1. Question number 2 is, how many squares will be in the 20th term? Right? So that is what you need to do. Well, let me explain you once again. These are the different terms. This is our term number 1, this is 2, this is 3. We are calling them our numbers, right? So here, n is 1, n is 2, n is 3, and so on. It increases, correct? What you see here is how many are shaded and how many are not shaded. So you find that in each, 1 is shaded. That is fixed. How many are not shaded? In this case, let me write here not shaded. Here not shaded are 2, and here 1, 2, 3, 4. In this case 1, 2, 3, 4, 5, 6. So what do you see? So if you make a table, for example, like this, writing down the term number which we are calling n as 1, 2, 3. Here you write shaded, not shaded. So in shaded, we are getting 1 for each, right? And in not shaded, in the first case there are 2, in the second case there are 4, in the third case there are 6. So, are they related with the first one? I think they are. So this number here is always 1. And this number here is 2 times n, right? This is number here is twice this number. 2 times 2 is 4, 2 times 3 is 6. So this is 2 times n. So now we get a rule, right? So our pattern rule is 1 plus 2n. So that becomes our pattern rule. Do you see that? So this expression 1 plus 2n gives you the pattern rule. Now, using this rule, can you find the number of squares in 20th term? Yes, we can. In 20th term, n equals to 20, and therefore the value will be 1 plus 2 times 20. Twice 20 is 40, correct? So we get 41. Do you see? Using the pattern rule, it is kind of simpler to find the answer. I hope now you appreciate how algebra helps to solve such questions. Now here is a question for you. This time what I've done here is shade it in a different direction, right? So what I would like you to do is make a T-chart to think how to answer such a question, correct? So in this chart, you are going to write term number here, which is n for us. Then you will say shaded and not shaded. Once you fill this up, you will get a rule. So you can pause the video, answer, and then look into my solution, right? So what we say here is the n is equal to 1, 2, 3, right? So that is the value of n for us. We can write here n is 1, n is 2, n is 3. Now shaded. So these are shaded. In the first one, we have shaded 2. In the second one, we have shaded 3. In the third one, we shaded 4. And how many not shaded? In the first one, 1, and then we have 2, and then we have 3. Now, can you relate these numbers with 1, 2, 3, the n value? That is the question for you. If you can write your rule, right? So, now write your rule. Do you understand? Once you write your rule, then find the number of squares in 50th term. That means if you extend this, I want to know how many squares will be in this term. Correct? That's your question. Well, you can see the pattern, right? So 1, 2, 3, 4, 1 is 1, 2 is 2, 3 is 3. So 50 will be 50, correct? Now this 2 is 1 more than 1. 1 more. So this will be 51. And if you add them, you get your total, correct? So that is your total. In the first case, it was 3, then 5, then 7. In this case, it is going to be 101. So that's your answer. But now again, I have not given you the rule. So the question here is to write down the rule from whatever we have done in terms of n. Perfect. Can you do that? So post your answers after writing the rule. Right? I hope that helps. Feel free to share your views. If you like and subscribe to my video, that'd be great. Thanks for watching and all the best.